Hello and welcome again. This is Juma. So we are doing our last lesson, which will be lesson 8 on metals. So we wind up with the chemical properties. We have two chemical properties to discuss. So in lesson 7 we discussed most of the chemical properties. So here we are going to discuss reaction of metals with chlorine, then reaction of metals with concentrated acids. Then we will wind up by looking at the uses of metals as well as the pollution effect of extraction of metals on the environment and the measures that can be taken or should be taken to control the pollution effect of extraction of metals. So without wasting much time, reaction of metal with chlorine. Metals react with chlorine to form metal chloride. For example, sodium reacts with chlorine to form sodium chloride and most of the metals. But I want to draw your attention to iron particularly. Now iron, as I mentioned in the previous lesson, iron, we have iron with two oxidation numbers, iron 2 and iron 3. When chlorine reacts with a metal where there are two oxidation numbers, the chloride of a higher oxidation number is formed because it is more stable. So in this case, when you react chlorine with iron, iron 3 chloride is formed instead of iron 2 because iron 3 chloride is more stable than iron 2. However, I have indicated there Lb. Note this. When chlorine is passed over iron filings, mostly you find that it is iron 3 chloride that is formed. However, sometimes in the exam students confuse. When it is hydrogen chloride that is reacted with iron, whether in solution or gas, when this gas is passed, hydrogen chloride gas is passed over iron, metal, iron wool, a green solid is formed and the green solid is iron 2 chloride. So take note, because sometimes students confuse this a lot, iron 2 and iron 3. Iron 2 is formed when you use hydrogen chloride gas, but when you use chlorine, iron 3 chloride is formed and is a black solid. So let me just project notes for those who may want to write the notes on the same. I've given even more examples in the notes. And then we look at the last chemical property of metals. So these are the notes on the same. Reaction of metals with chlorine. So there we have example of sodium react with chlorine to form sodium chloride. Aluminium the same. And the observations that will be observed when that reaction is taking place. And then lastly, those other metals, copper, zinc, iron as well, reacting with the chlorine to form the respective metal chlorides. Then when chlorine dissolves in water, it forms dilute hydrochloric acid, and dilute hydrochloric acid will react with those metals as indicated. Sodium, the reaction is explosive, as we have discussed in lesson number 7, reaction of metals with dilute acids. Then the others, aluminium, iron, zinc, will react respectively as indicated. Then also in lesson 7, we noted that copper does not react with dilute acid. The reason is because it is below hydrogen in the reactivity series, hence it cannot displace hydrogen from the acids or from the dilute acids. And that will mark the properties of chlorine with reacting with metals. So let's look at the last property, which is a reaction of metals with concentrated acids. So lastly, reaction of metals with concentrated nitric acid and sulfuric acid. So concentrated sulfuric acid and nitric acid are oxidizing agent. Sodium reacts explosively with concentrated nitric acid and sulfuric acid, as we noted in lesson 7. Then aluminium reacts with concentrated sulfuric
sulfuric 6 acid or sulfuric acid to form a salt, water, and sulfur 4 oxide, as indicated there by the equation. However, aluminium does not react with concentrated nitric 5 acid because the acid is a strong oxidizing agent and produces an insoluble aluminium oxide layer, which prevents further reaction. And similarly, concentrated nitric acid does not react with iron for the same reason. It is a strong oxidizing agent. It oxidizes iron, forming an insoluble triion tetraoxide, which prevents any further reaction. And this is the reason why containers or tanks transporting nitric acid are made of aluminium and iron, because the acid initially will first react with tanks or the containers, forming insoluble layer. That insoluble layer forms an additional protection layer, and that is why those tanks are made of aluminium or iron for that reason. Then we have the other metals will react as follows. So you have zinc will also react with concentrated sulfuric acid to form zinc sulfate, as well as copper. So iron reacts with sulfuric acid as indicated there by the equation, forming iron 3 sulfate, water, and sulfur 4 oxide gas. Then copper as well will react with concentrated sulfuric acid to form copper 2 sulfate, water, and sulfur 4 oxide as shown. So you take note that when metals react with dilute acid, they form salt and hydrogen gas. But here you can see no hydrogen gas is formed, but instead either for sulfuric acid, concentrated sulfuric acid, you have sulfur 4 oxide formed, and for concentrated nitric acid, you have nitrogen 4 oxide formed instead. So you have salt, water, and an oxide gas of the acid is formed, and that will mark the properties of metals when they react with air, water, dilute acids, chlorine, as well as concentrated acids. So next we look at the uses of metals. Uses of metals. Sodium. One is used in, sodium vapor is used in lamps. So the street lamps, the yellow color you see produced by the street lamps or bulbs, the yellow bulbs, is because of the sodium vapor inside them. A mixture, number 2, a mixture of sodium and potassium is used as a coolant in nuclear reactors because it has low melting point and a good conductor of heat, so it is used as a coolant in nuclear reactors. 3, molten sodium is used as a reducing agent in the extraction of titanium from titanium 4 chloride. Sodium is used in the manufacture of tetraethyl lead, used as an engine anti-knock additive to petrol. Sodium is used in the manufacture of sodium peroxide and sodium cyanide. And not forgetting, sodium chloride is used as food additive. Aluminium, let's look at the uses for aluminium metal. So uses of aluminium. 1, aluminium is used for making of cooking pots and brewing vats because it is a good conductor of heat, resistance to water and steam. It also has good appearance and it is not poisonous, it is non-toxic. 2, aluminium is used for making of overhead electrical cables, used because it is a good conductor of electricity. 3, aluminium foil is used for food packaging. 4, when powdered and suspended in oil, aluminium is used as a paint 5. Aluminium is used for making of mirrors. 6. Aluminium is used in thermite reaction for welding iron and steel, and extraction of some elements such as chromium, iron, cobalt, manganese, and titanium. 7. Aluminium is used to remove dissolved oxygen from molten metals. And finally, 8. Corundum, also known as emery, is a natural oxide of aluminium used as an abrasive. Then let's consider the uses of copper. Copper uses, number 1, used to make electrical wires, cables, and fittings because it is a good conductor of electricity. Copper is used in making cooking pots, boilers, and condensers due to its excellent electroconductivity. Copper is used in making of jewels and coins due to its hardness, attractive appearance, and high resistance to corrosion. Copper is used to make alloys with other metals such as brass, bronze, and German silver, which we are going to see the uses of alloys just after iron. We refer, because iron has so many alloys, so together some of them are going to be alloys made of iron and copper. An alloy is a molded mixture of 2 or more metals. So the resulting, when it dries up, what it forms, that material is called an alloy. And usually an alloy has better properties than any of the individual metals that make it. So zinc, uses of zinc. Zinc is used for coating iron objects, what we call galvanization. For example, iron sheets. It is also used in making the casings of dry cells, the negative terminal, like what we saw in the electrochemical cell. Zinc also is used in making of alloys such as brass. So below are uses of iron and the alloys made of other metals. So for iron, we're going to see the uses of iron under the alloys below. So an alloy, basically, as I've said, is formed by mixing molten metals, and then they are allowed to cool. The alloys formed usually have low melting point and have better, or they are stronger than the individual metals. So let's see some of these uses. So some of these alloys, one is brass. Composition is made of copper and zinc. Properties, it is harder than pure copper. Then it has an appearance of gold, so it is gold colored. Uses used to make utensils, screws, and radiators. Then another alloy is bronze. Bronze is made of copper and tin. It is harder than pure copper. It is used to make machinery and decoration works. Then we have German silver. It's made up of 3 metals, copper, zinc, and nickel in the composition indicated there. It is harder than copper, and then it is corrosion resistant. It is used for electroplating. And then we have steel. Now steel has very many alloys. The steel, remember, the largest percentage is going to be iron. As we saw, purification of iron leading to formation of steels. We have stainless steel, we have carbon steel, milled steel, high density steel. There are so many forms of steel which we are going to see. So stainless steel is one of them, made of 74% iron, 18% chromium, and 8% nickel. Properties, it is tough and does not corrode. Uses, it is used to make cutlery, surgical instruments, kitchen sinks. Another alloy of steel, we have or of iron, it is tungsten steel, which is made of iron and tungsten. It is tough, harder, even at high temperatures. It is used for making edges of high-speed cutting tools. Another alloy of iron, we have manganese steel, which is made of iron and manganese. Properties tough and springy. It is used to make drill bits and springs. And then we have milled steel, which is iron and carbon in the composition indicated. Properties stronger and harder than pure iron. It is not brittle. It is used to make car bodies, axles and bridges. Then we have medium steel, which again is carbon and iron in the composition shown. Tough than milled steel. It is used to make springs and chains. Then we have high carbon steel, which is iron and carbon in the percentage composition shown. It is hard and brittle. It is used to make chisel cutting tools and razor blades. Then we have cast iron, which is iron and carbon in the shown percentage. So properties, this one is easily molded and it is used to make gearbox, engine blocks and brakes. So you can see that for iron has so many uses. It has very many alloys, and most of them are just iron and carbon. All you need is just to change the percentage composition of carbon and iron, and you have a different form of iron or steel, and it will have different application. So the last alloy is an alloy of aluminium called duralumin. So duralumin is 95% aluminium, then 1% copper, 1% small of other elements. Properties, it is strong but light, low density but very strong. Uses, it is used to make parts of aeroplane, rockets, cans, foils and kitchen utensils. So those are some of the alloys and their uses. So let's look at the environmental effects of industrial production or extraction of metals on the environment and the measures to reduce pollution. So these are the pollution effects caused by extraction of metals by factories or industries. One is that the dust from mining or processing plants can be harmful to both plants and animals. Now, like for example, for animals can cause respiratory problems. For plants, that dust, a lot of it accumulates on plant leaves, which interferes with the photosynthesis process, which can lead to yellowing of leaves and even leaves falling off, hence even the plants dying. 2, noise from processing plant operations or transport of raw materials is pollution to the environment. 3, waste products like carbon dioxide and sulfur oxide are harmful to the environment. 4, mining operations disfigure the land. 5, runoff water which wash the unwanted materials into the rivers and lakes. Now, some of these materials, especially heavy metals like mercury, are poisonous to aquatic animals. And then 6, hot water from cooling engines when allowed into the rivers and lakes rise the temperature of water, driving out dissolved oxygen from water, hence killing aquatic animals by suffocation. So those are the pollution effects. Then there are measures that we can take to reduce the pollution effect. So measures to reduce pollution effect include Commercial utilization of emitted gases, for example, carbon 4 oxide should be recycled, as well as sulfur 4 oxide. They can be used, for example, sulfur 4 oxide can be used in the manufacture of sulfuric acid. Fitting chimneys with wet scrubbers by passing the smoke through water spray that dissolves soluble gases like carbon 4 oxide and sulfur 4 oxide. Then use of electrostatic precipitators to remove soot and dust from the exhaust gases before they are discharged into the atmosphere. And finally, cooling hot water from the engines in factories before it is discharged into rivers and lakes to avoid raising the temperatures of water in streams and in lakes. It has been my pleasure doing metals with you, plus other topics. So we have done so far 5 topics. We did energy changes, reaction rates, radioactivity, electrochemistry, and metals. All these topics, I have covered them and posted them online. For those who are accessing them through the YouTube, as I've always said, please subscribe so that you can access all those topics that I have done. I've done this to help those who are studying from home, so that at least when we resume back to normal business, you will not lag behind as well. It is going to facilitate our revision. So all the candidates, wherever you are, I wish you all the best. This was your chemistry teacher, Teacher Juma. Stay safe and God bless you so much.